Good morning, Alicia and Justin. So today is the start of our new unit, Introduction to Probability, and this will be chapter 1 in our workbook. So we're basically going to go through the different activities and explore the different ways that we can see probability. So for this slideshow, I provided you with a worksheet to go along with it. So basically, as we go through this video, feel free to pause and write down any notes or write down any definitions or any blanks that I've put on this worksheet for you. These will be your notes for this particular unit. So in order to do probability, we have to remind ourselves of some important skills. So you may recall that we've seen this before at the beginning of the course and when we did the tax unit. So it's very important that we understand that probabilities can be written in 3 different ways. So we can write them as fractions, we can write them as decimals, and we can write them as percents. It's very important that we're able to interchange between these 3 forms of writing probabilities. Okay, the most common form that you'll see is probably a fraction and percents. Okay, so for example, for 1/10 as a fraction, in order to get that to a decimal, I divide the numerator by the denominator. So I'm taking 1 and I'm dividing it into 10. Okay, when you do that on a calculator, you'll get 0.1. Now to change 0.1 into a percent, you are going to multiply by 100%, okay, to get our 10%. To go the other way with it, so if I have a percent, I can divide it by 100 and that will give me the decimal. If I want to turn a fraction or turn a decimal into a fraction, you turn the fraction using place value and reduce to lowest terms. So essentially 0.8, you can write that as 80 over 100, and you can reduce that to 4 over 5. So we're going to take a look at a few examples so that you know exactly what I'm referring to here. So on your sheet, you'll see that there's a chart. We're going to fill in the chart together. So we've got fraction, decimal, percentage. So we've got 2/7 as a fraction, we've got 0.59 as a decimal, and as a percent, we've got 29.5%. So we're going to fill in this chart accordingly. So take a moment before we go through it and fill in the chart. So take a moment to pause the video, go through and do this chart before we take a look at the answers. So I hope by now that you've gone through and done this chart by yourself. Okay, so let's take a look if we were right. So to go from a fraction to a decimal, we're just going to take the numerator, divide it by the denominator, and on our calculator it should give us a decimal place. Okay, so for this particular one, you should have 0.29. Now to take 0.29 into a percent, we're just going to be multiplying that by 100, and we're going to get 29%. So if you did that, good job for you. Okay, let's take a look at the next one. So now we have a decimal, and we want to go from a decimal to a fraction as well as to a percentage. Okay, so in order to go from a decimal to a percentage, we're going to again multiply by 100%, so we get 59%. Okay, for this one, you can take the percentage, or you can just move this over to get 59, and you can take 59 divided by 100. For this particular fraction, we cannot reduce it anymore. So reducing means that we cannot divide a number equally into both the numerator and the denominator. So this is the lowest possible terms that we can possibly have for this particular fraction. Okay, taking a look at the other example, we're given a percentage. So to go from a percentage to a decimal, we're going to be dividing by 100. Okay, to get our decimal 0.295. Okay, and again, we can put the percentage over 100, so 29.5 over 100 to give us a fraction. So again, this fraction cannot be reduced into the lowest terms. This is as far as we can go. We cannot divide any numbers evenly between the numerator and the denominator. Okay, if you have any questions about this, please come to me after the video and we can go through it again. Okay, I'd like you to take a look at your workbook. Okay, so turn to this page, the first page of chapter 1. Okay, let's take a look here. So it's on page 3 of your workbook. Okay, so we have a person here saying, finally a winner, and looks like they're drinking some sort of coffee. And the other guy's like, how much money did you spend trying to win a free cup of coffee? Okay, so as you can see, she had about 1, 2, 3, 4, 5 cups of coffee before she got a winner. Okay, so we see probability in everyday life, in contests, lotteries, and games. Okay, so particularly right now, Tim Hortons has their roll up the rim to win. So that would be an example. They provide the customers with their chances of winning. So a chance of winning would be an example of a probability. Okay, so I just want to make you aware of the different ways that probability can be part of our everyday life. So moving on to the actual definition of probability. So probability is most likely written as a fraction, and we're going to be talking about ratios later in this unit. But for now, when we're talking about probability, this is what we're actually looking at. So when probability is written as a fraction, the numerator, so the number on top, represents the total number of successful attempts, and the denominator represents the total number of attempts altogether. Okay, so we've got successful attempts over total attempts. Okay, so if you take a look at your worksheet, there's a spot to write this information. So if you need to pause the video, pause it so that you can get this information down. Okay, so what does 6 over 13 actually mean? This means that there is 6 in 13 chances of something happening. Okay, so if we take a look back at our example here with the coffee, okay, so she did 5 coffees altogether, so that would be her total attempts. So she had 4 or 5 coffees, so that's her total attempts at trying to win this. Okay, her only successful attempt was the one time. Okay, so if we were going to write this as a probability, we would have 1 over 5. So she had she had 1 in 5 chances of winning a coffee. Okay. When we're looking at probability, there's 2 different kinds of probability, and we have to remember to always put these in the lowest terms. So when we're writing a fraction, we need to remember that we always want the lowest term. So we want an equivalent fraction that cannot be reduced any further. Okay, so for example, let's take a look on the next slide. We have 25 over 100. Okay, so we have to ask ourselves, is there any numbers that can divide into the numerator and the denominator evenly? Okay, I like to start off by going 2, take a look to see if 2 can go in both. I like to take a look to see if 4 can go in both. Okay, in this case, 25 can actually go into 100 evenly. Okay, so when in doubt, see if the numerator can go into the denominator. If not, try dividing by 2 first and see if 2 can go into both numbers evenly. So when we take 25 and divide it into 100, okay, we are left with 1 over 4. So 25 divided by 25 is 1. Okay, 25 into 100 goes in there 4 times. Okay, so if, for example, I had 25 successful attempts out of 100 total attempts, okay, my fraction or my probability would be reduced to 1 over 4. So it's very important on a test and on assignments that we're reducing our fractions to the lowest possible terms. I'll be looking for that. Okay, when we're talking about probability, we're going to be taking a look at 2 different kinds. So we have theoretical probability and we have experimental probability. So as you'll note, there's a spot on your worksheet to write these definitions. So if you need to pause the video again to write down this information, please do that now. Theoretical probability is the chance of something happening. Okay, so it's usually calculated based on information that you're given. Experimental probability is the chance of something happening based on experimental results. So for example, you might do an experiment and rolling dice and seeing how many times you get particular numbers on a die. That would be an experimental probability. A theoretical probability is we take a look perhaps at a deck of cards and we try to think about theoretically what are the chances of me getting each suit of the card. So for example, what are the chances of me pulling out a heart from the deck of cards? Whereas the experimental probability, we actually take the deck of cards, we do an experiment, and we see exactly what the results are. Okay? So an example of a theoretical probability would be if I gave you something like this. So the lottery sells a limited number of tickets. So they sell 120,000 tickets. So what are your chances of winning the grand prize of $1 million if you purchase 1 ticket, 4 tickets, or 10 tickets? So again, this is a theoretical situation. Okay, so we haven't gone out and done any experiment. I'm just giving you this information, and I want to know theoretically what are my chances of winning this prize with the amount of tickets that I'm going to purchase. Okay, so remember that when we're writing probability as a fraction, we have the number of successful attempts on top and the total number of attempts at the bottom. Okay, so in this case, the total number of attempts would be 120,000 tickets, because that's the amount of tickets that we're going to have for this experiment, or for this theoretical experiment. Okay, so for me to win the ticket, or to win the prize based on 1 ticket, okay, 1 ticket would be my successful attempt. Okay, so we would write the fraction 1 over 120,000. Okay, we have to make sure that this fraction cannot be reduced any further, which it cannot. Okay, when we take a look at 4 tickets, okay, so 120,000 would still be the total attempts at trying to win this prize. Okay, however, the success rate would be based on 4 tickets. Okay, so we are going to write this as 4 over 120,000. Okay, as you can see, there's an equal sign here, so that must mean that we can reduce this fraction further. Okay, so if we reduce the fraction further, we actually get 1 over 30,000. So I took the numerator and divided it into the denominator to get 30,000, and I took 4 divided by 4 to get 1. Okay, so that would be my chance of winning with 4 tickets. Okay, what about with 10 tickets? Okay, so again, you would write 10 over 120,000. Okay, again, we can reduce this further, so we can take the numerator, divide it into the denominator to get 1 over 12,000. Okay, so these would be, the last fractions here would be my chances of winning the 1 million prize based on how many tickets that I had purchased. Okay, if you have any questions about this, feel free to come talk to me after. For practice, okay, I would like you to look at page 4 in your workbook to do numbers 1 and 5. So this is based on the converting between fraction and percent. And then I would like you to do the whole of section 1.1 where it starts. Okay, again, if you have any questions, please feel free to ask me after this lesson. Thank you, and please come back upstairs.